A short tour of the universe. What is the universe? The universe includes all matter and energy everywhere, including the Earth, solar system, galaxies, black hole, interstellar matter, and space, regarded as a whole. The large-scale structure of the universe refers to mapping and characterization of the observable distributions of matter, light, and space, on scales of billions of light-years. Astronomers have been able to determine that there is a hierarchical organization to the universe, with matter organized into progressively larger structures from atoms, to solar systems, galaxies, clusters, and superclusters, filaments, to black holes, then a continued structure known as the end of greatness. The large-scale structure begins at the galactic scale. Galaxies are gravitationally bound assemblages of stars, dust, gas, radiation, and dark matter. Most contain vast numbers of star systems and are located at enormous distances from the Milky Way galaxy, such that the light reaching Earth from these galaxies was generated billions of years ago. Galaxies are classified into 4 basic types, including spiral galaxies, barred spiral galaxies, elliptical galaxies, and irregular galaxies. Galaxies are organized into clusters and superclusters, held together by their mutual gravitational attraction. These groups or clusters are separated by voids characterized by relatively empty space that is apparently devoid of luminous matter. The Milky Way galaxy is part of the local group, which also includes the large Andromeda spiral galaxy, the large and small Magellanic Clouds, and about 20 smaller galaxies. Galaxy clusters are of several different types. Regular clusters are spherical with a dense central core, and are classified based on how many galaxies reside within 1.5 megaparsecs of the cluster center. Most regular clusters have a radius between 1 and 10 megaparsecs, and masses of 10 to the power of 15 solar masses. Irregular clusters generally have slightly lower mass than regular clusters and have no well-defined center. Virgo cluster is the example of an irregular cluster. Supercluster. Superclusters typically consist of groups or chains of clusters with masses of about 10 to the power of 16 solar masses. The Milky Way galaxy is part of one supercluster, centered on the Virgo cluster, and has a size of about 15 megaparsecs. In contrast, the largest known superclusters, like that associated with the Coma cluster, are about 100 megaparsecs across. Recent advances in astronomers' ability to map the distribution of matter in space reveal that about 90% of all galaxies are located within a network of superclusters that permeates the known universe. Every known galaxy shows a redshifted spectrum, meaning they are all moving away from the Earth in all directions. The farther away the galaxy or cluster is from Earth, the greater the redshift, and the faster it is receding. The same is true for other observational pairs. The farther apart any 2 galaxies are, the greater the redshift between them, showing that the universe is expanding, like the surface of an inflating balloon. In fact, wherever we look with telescopes, the sky is full of galaxies. Scientists estimate that there must be about 10,000 billion stars in the universe, more than the number of grains of sand on all the beaches on Earth. There are at least 100 billion galaxies in the universe. Some are enormous, containing hundreds of billions of stars. Others are much smaller, sometimes containing fewer than 1 million stars. There are many more small galaxies than giant galaxies. Even though the dwarf galaxies tend to be swallowed by their larger neighbors over time. We live in a galaxy of about 100 billion stars called the Milky Way. Traveling at the speed of light, it would take 100,000 years to cross the Milky Way. Our Sun lies between 25,000 and 28,000 light-years from the center of the Milky Way. The largest galaxies in the universe stretch up to 2 million light-years long. There are about 10 million superclusters in the observable universe. No one knows how big the universe is, but it has been expanding since it formed in the Big Bang 13.7 billion years ago. The distances are so great that cosmologists measure them in terms of light years. The distance light moves in space in a year, which is equal to 9.5 trillion kilometers. And the universe is billions of light years apart. Thanks for watching. Please like, comments and subscribe to my channel and activate the bell icon to get new video updates.